Section 10.2, example of a hyperbola. 4y squared minus 9x squared plus 18x equals 45. And we want to try to write this equation in the form y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1 in order to identify the features of the graph. Because the x squared and y squared have opposite signs, that's a clue that it's probably going to be a hyperbola. It could be a pair of straight lines actually too, but most likely it would be a hyperbola. Okay, so we want to try to put this in this form. The first step is to we only have one y squared term, only one y term. It's a y squared term, so we'll leave that alone for the time being. But we have two x terms. We have an x squared term and we have an x squared term and a term where x is not squared. We want to factor out the coefficient of x squared, so factor out the -9. Divide both coefficients by -9. Inside parentheses, we'll have x squared minus 2x. And we can copy the rest of the equation. And now we want to make this into a perfect square. So half of 2 is 1, 1 squared is 1. So we want to add 1 in order to make this into a perfect square. If we add 1 to the left side, we have to add 1 to the right side. But really this 1 that we're adding is inside parentheses with the -9 on the outside. So what we're really adding is a -9 times 1. So we want to add that to the other side of the equation as well, so that's equivalent to the original equation. And now we can factor the left side, the equal sign. X times x gives us x squared. We need two numbers to multiply to 1 and add up to -2. What works is -1 and -1. And you can check with the FOIL method. X times x is x squared. Outer product -1x. Inner product -1x. Add those, you get -2x. Last times last, -1 times -1 is 1. Okay, so that's our equation now. And we can write this in exponent form. X minus 1 times the quantity x minus 1. You can write that as the quantity x minus 1 quantity squared. Write it more compactly. Okay, so this will be now x minus 1 quantity squared. I left the rest of it the way it was. And now we're starting to look more and more like the standard form. The standard form, instead of an equals 36, has an equals 1 here. So we want to divide everything by 36 to get that equals 1. 4 divided by 36 is 9. 4 into 36 goes 9. 9 into 36 goes 4 times. 36 divided by 36 is 1. So we're almost there. We have y squared over 9 minus x minus 1 quantity squared over 4 equals 1. In fact, the book often stops at this point because it's close enough to standard form to identify the features. But if we want to write it exactly in standard form, y is the same as y minus 0. So we can write this as y minus 0 quantity squared. Standard form on the bottom has a number squared. Well, 3 squared is 9. 2 squared is 4. And this is now exactly in standard form. And we can now identify the features of the graph. K is the number inside parentheses with y. That's going to be 0. H is the number inside parentheses with the x. That will be 1. B is the number on the bottom underneath the y, which is 3. A is the number underneath the x, which is a. Sometimes the book switches the a and the b, but I like to always put the b under the y and the a under the x. Okay, so center HK will be 1, 0. The vertices, because the y squared is the one with before the minus sign, the vertices will be up and down from the center, and we'll go up 3 and down 3 from the center, and the co-vertices are going to be, the A is going to be the co-vertices. That'll be left and right from the center. The slopes plus or minus b over a, which in this case plus or minus 3 over 2. So these are the slopes of the asymptotes. So from the asymptotes, so you start at the center, which is 1, 0, and to get the points on the asymptotes, if you go over 2 and up 3, you'll get another point, and you can connect the dot, connect that point with the center with a dotted line. And if you go 2 to the right and down 3, you'll get the other asymptote. So I put the asymptotes in with dotted lines, and that's now enough to sketch the graph. The vertices we said were well, the center is 1, 0. For the vertices, you go up 3 and down 3. So those red dots there are the vertices, and then if you extend the vertices toward the asymptotes, you'll get the two pieces of the hyperbola. Okay, so in order to get the focus, some of the applications require a knowledge of the focus. We don't really need the focus so much for the graph, but if some of the applications you do, and there's a formula for that. I actually applied the focus on the graph here, but in order to get the focus, use the formula C is equal to square root of a squared plus b squared. In this case, it's square root of 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So square root of 13. Square root of 9 is 3, square root of 16 is 4. So we know it's going to be somewhere between 3 and 4, and through trial and error, we can estimate it to be about 3.6. So the focus will be 3.6 from the center. It'll be past each vertex from the center. Just some additional terminology. The line connecting the two vertices is called the transverse axis. The line connecting the two covertices is called the conjugate axis. And that concludes this presentation.